Yo, what's up, my dear viewers and vieweresses? Today we've got a nice 4Q kata called regular expressions for binary numbers divisible by 5. Define a regular expression which tests if a given string representing a binary number is divisible by 5. Examples are simple. This is a pattern which I guess we must write. And the match function is called on it. And if it's true or if it's false. This can be solved by creating a finite state machine that evaluates if a string representing a number in binary base is divisible by a given number. The detailed explanation for dividing by 3 is here. The FSM diagram for dividing by 5 is here. Alright, let's car. Let's trade. Let's car. This is already a partial solution, you know. This got me thinking, maybe this kata is for Q because like it's so hard to follow this Asvitalski. I don't know if that's like a dude. Alexander, yeah, that's a dude. I don't know if this kata is difficult because his suggestion is weird. B. Does this maybe turn ordinary numbers into binary numbers? B, let's say Python B. What is the B character in front of a string literal? Yeah, it turns it into bytes, man. Oh no, it's not like that. Maybe it turns it into bytes, you know. We can test this out real quick. Python 3, and then we say C equals, it's like this, right? Well, this is probably gonna be a long one. Alright, let's, yeah, this thing turns it into binary. That's so cray. Alright. Alright, so if he has done so much, let us adapt to these guys' ways. Let's adapt to this Alexander's ways. And first, let us look at what we have. He already made a pattern which says R, a row string, and then it should end. He's looking at the end of the string, and this 0 can occur multiple times. A star means asterisk means, I don't know if 1 or multiple times or 0 or multiple times. Regex character asterisk. Where are you? Alrighty then. Hey, where are you, asterisk? Where are you, asterisk? Greedy. Repeat it as many times as possible. Yeah, but where's the asterisk object? Yo. asterisk object, asterisk object. Oh, it's supposed to be up here then, somewhere. It says asterisk, asterisk. Doesn't match. Instead, it's that the previous character can be matched 0 or more times instead of exactly once. This is 0 or more times. This is 0, and this can occur 0 or more times, and this should be the last group before the string ends. And this signals that the string should end with 0 or 0 or 101. Alright, so this is we're looking for some specific binary pattern. And if we look at the tests, okay, sample test, true, 0 is divisible by 5, I guess. And then false, ABC, empty string, and all these kinds of types of string, and he formatted the string using this syntax, which is really interesting. I didn't know this existed. These two are false. Yeah, I mean, because this thing, for example, this one does match this pattern, you know, and I guess this will be a false positive, you know. No, 12, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9th test. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, the things that it doesn't pass are these two strings. But this is really a false. Why is this? I think this pattern should pick up this as true. Oh, because no, this is 0 or more times, so this is like 0, this can be non-existent, and then it's 101 or 0 ending, and this is ending with 101. This is getting me really confused. Okay, for AXPS in tests, tree pattern should work with. So this thing, what it does, it says like maybe because this thing matched. Oh yeah. Yeah, maybe because this thing, no, it matches only at the end. And this is OR. Pipe character is OR. OR operator. Okay, so this thing bool rematch pattern, it tries to make a match with this pattern and a string. AXP, I don't know what AXP is. So yeah, expectations. Expectation. Alright. This should match with expectation. False or true. Okay. Now look in the instructions. I don't know why the explanation for dividing by 3 is here. If I understand correctly, why does this FSM accept binary numbers being divisible by 3? Finite state machine. Thanks in advance. Muffle. And this one is just black. Yo. I'll just visit his website. This is demo page. Alright, so this really doesn't help. The FSM diagram for dividing by 5. So let's find the finite state machine diagram. But let's first, what is even a finite state machine? Let's read about that. I think that will help us get it. We can search Wikipedia. So classes of automata. Clicking on each layer gets an article on that subject. Combinational logic, finite state machine, push down automation, and Turing machine. And everything is in the automata theory. Okay, finite state machine, finite automation, or simply a state machine, is a mathematical model of computation. It is an abstract machine that can be in exactly one of a finite number of states at any given time. Alright. So this thing can be either divisible by 5 or modulo 1, 2, 3 or 4. The FSM can change from one state to another in response to some inputs. The change from one state to another is called a transition. An FSM is defined by a list of its states, its initial state, and the inputs that trigger each transition, just like I trigger my Tech 9 in the hood. Finite state machines are of two types: deterministic and non-deterministic. A deterministic one can be constructed equivalent. A deterministic finite state machine can be constructed equivalent to any non-deterministic one. Oh, heck Wikipedia. Let's look at this website only for people of 18 years or older. And let's see, graphics programming language agnostic, frameworks, tools, programming languages, general, okay, foundations. Donald Knuth, isn't that the guy who wrote The Art of Programming? The Art. Let's do this still alive, man. Yeah. Nothing found. Yo, I mean. The Cathedral and the Bazaar. The Cathedral and the Bazaar. Oh, I remember this. The Cathedral and the Bazaar is the book about an open source something. It's an essay and letter of book on software engineering methods based on observing the Linux kernel. You could do that, but observe how the Bitcoin was made and blockchain and stuff like that. Musings. Because now you only have an audiobook with with red. Alright, security engineering. Getting real. Getting real. A must read for anyone building a web app. Let's get real. So you can just read that, I guess. Best kept secrets of a peer code review. NASA software measurement handbook. I know this is some really boring document because and you need Scribd to read it. Algorithms. Let's build a compiler. How to think like a computer scientist. 97 things every programmer should know. Clever algorithms. Flow-based programming. I am a bug. I am a bug. It's not fun, I guess. Am I a bug.com. That's amibookshare.com. Yo, that's termite and pest control. Family owned and operated. Yeah, how else is gonna be operated? Think stats. Probability and statistics for programmers. The architecture of open source. Oh man, that's actually interesting. Black code. 50 lines or less. Oh, I think that's like instructions for open source, not like the analysis of open source applications. I don't know. Depends on your stature, statura, prior or the lateral. Get the feather check split. Think stats. Again, these are not these are resources for learning only. Type theory and functional programming. Is parallel programming hard? Introduction to information retrieval. How computers work. Maybe this is a good example for finite state machines. Nah. The definitive guide to building code quality. How to write unmaintainable code. You can pick that when you have a very bad job. Okay. There's some Napoleon quotes right over there. Yeah, this is no good right now. But I'll keep that. I'm interested in this. So, FSM, finite state machine. The finite state machine has less computational power than some other models of computation, such as Turing machine. The computational power distinction means there are computational tasks that a Turing machine can do, but a finite state machine cannot. This is because finite state machine's memory is limited to the number of states it has. Finite state machines are studied in in the more general field of automata theory. I guess that's as general as an apple. Example, a coin-operated turnstile. Okay. An example of simple mechanism that can be modeled by a state machine is turnstile. A turnstile used to control access to subways and amusement park rides is a gate with 3 rotating arms at a waist height, one across the entryway. Initially the arms are locked, blocking the entry, preventing patrons from passing through. Depositing a coin or token in a slot on the turnstile unlocks the arms, allowing a single customer to push through. After the customer passes through, the arms are locked again until another coin is inserted. So it's like this, it's locked, coin, it's unlocked. If you put another coin, there's still unlocked, but if you push, it's locked, and I guess this is the coin, and if you push, it's still locked. Alright, that's a fancy way of explaining the obvious, you know, but okay, I see what they're getting at. Considered a state machine, the turnstile has 2 possible states, locked and unlocked. There are 2 possible, like, our machine could be like divisible by 5 and not divisible by 5. There are 2 possible inputs that affect its state, putting the coin and pushing the arm. In the locked state, pushing on the arm has no effect. No matter how many times the input push is given, it stays in the locked state. Putting a coin in, that is giving the machine a coin input, shifts the state from locked to unlocked. In the unlocked state, putting an additional coin has no effect. That is giving additional coin inputs does not change the state. However, a customer pushing through the arms giving a push inputs locked. Now, this is all fine, and right here it says some kind of practical solution can be achieved with a finite state machine. Now that gets me thinking, like, oh, how should I make a finite state machine? But right over here we are not making a finite state machine, we're just making a regular expression pattern. This one says, this can be solved by creating a finite state machine that evaluates if a string representing a number in binary base. So let's Google this, you know, or DuckDuckGo this and say how to make a finite state machine out of regex pattern, a single regular expression pattern. Ooh, this is a good one. Designing finite automata. Interesting. In this video, and I guess convert regular expression is best started, part 1.
So you've been given the problem of converting a regular expression to a finite state automaton or a finite state machine?
Yeah, kind of. Although I don't know how would that work. Okay, because I cannot visualize how does that work in this way. The turnstile state machine can be represented by a state transition table, showing for each possible state the transitions between them based upon the inputs given to the machine and the output resulting from each. So we've got current state, two kinds of input, next state, and the output. None. Now I don't know for how long this is filming, but I have to finish soon because my memory will overflow. So let's finish it over here. We are in the middle of the theory. We made some very fruitful search engine search that resulted in this video. So see you in the next one.